Our universe is always moving. Planets orbit stars. Stars cluster into galaxies. Galaxies themselves are rushing through the vastness of space. But there's another kind of motion, one we can't see but experience every single moment. This motion is time. Time is what keeps everything from happening all at once. It's the invisible river that carries us from the past through the present and into the future. Without time, our universe would be a frozen snapshot, devoid of change, development, or the unfolding story of existence. Imagine time as a river constantly flowing in one direction. We, like boats, are carried along by its current. We can't see this river, touch it or hold it back. We can only experience its relentless flow. This flow from past to present to future is what makes time feel so linear and irreversible. We remember the past because it has already happened. We experience the present as it unfolds. The future, however, remains a mystery, waiting to be shaped by the choices we make in the present. Even though we can't control time, we've found ways to measure its passage. Clocks tick off seconds, minutes, and hours. Calendars mark the days, weeks, months, and years. These tools help us organize our lives and understand the rhythms of the natural world. The Earth's rotation gives us day and night. Its orbit around the sun defines a year. These celestial cycles have been our timekeepers for millennia, reminding us that we are part of something much grander than ourselves. Time leaves its mark on everything. We age as time passes, our bodies changing, growing, and eventually declining. Trees grow taller, their rings recording the passage of years. Mountains erode over eons, sculpted by the relentless forces of wind and water. History itself is a testament to time's passage. Empires rise and fall. Discoveries are made and forgotten. Stories are passed down through generations. Time is the canvas upon which the grand drama of the universe unfolds. For centuries, people believed time was constant, ticking at the same rate for everyone, everywhere. Then came Albert Einstein. Einstein's theory of relativity shattered this notion, revealing that time is not absolute but relative. Time, he discovered, is intertwined with space, forming a fabric called space-time. This fabric can be warped by gravity and motion. The faster you move, or the closer you are to a massive object like a black hole, the slower time passes for you relative to someone who is stationary or farther away from the gravitational source. Section 6. Time travel, fact or fiction? Time travel has long been a subject of fascination and speculation, captivating the imaginations of scientists, writers, and dreamers alike. But is it truly possible, or is it merely a figment of our collective imagination? Einstein's theory of relativity opened up tantalizing possibilities, including the idea of time travel. His groundbreaking equations suggested that time is not a constant, but a variable that can be stretched and compressed. This revelation has led to countless theories and experiments aimed at understanding the true nature of time. Could we journey to the past or leap into the future? The concept of traveling through time has been a staple of science fiction for decades, from H.G. Wells' The Time Machine to modern-day movies and TV shows. But how close are we to making this a reality? While time travel to the past remains firmly in the realm of science fiction, traveling to the future is theoretically possible, though technologically challenging. The idea hinges on the principles of relativity and the effects of high-speed travel on the passage of time. Remember, time slows down for objects moving at high speeds. This phenomenon, known as time dilation, has been observed in experiments with particles traveling close to the speed of light. The faster an object moves, the slower time passes for it relative to a stationary observer. If we could travel near the speed of light, time would pass much slower for us relative to someone on Earth. This means that astronauts on a high-speed journey through space could experience time at a different rate than people back home. A journey that might seem like years to us could be centuries or even millennia back home. This concept, often referred to as the twin paradox, illustrates the profound implications of time dilation. Imagine leaving Earth and returning to find that entire generations have passed in what felt like a short trip to you. We would have effectively traveled to the future. The possibilities are both exciting and daunting. As we continue to explore the mysteries of the universe, who knows what discoveries await us? Perhaps one day time travel will move from the pages of science fiction to the realm of scientific fact. Until then, we can only dream and continue to push the boundaries of our understanding. Section 7. The mysteries of time's beginning and end. Time, as we understand it, began with the Big Bang, the event that birthed our universe. This monumental explosion set into motion the expansion of space, creating the very fabric of reality as we know it. The Big Bang marks the starting point of time, a moment when everything we see and experience today was compressed into an infinitesimally small point. But what existed before the Big Bang? This question has puzzled scientists and philosophers for decades. Some theories suggest a pre-Big Bang state, a realm beyond our current understanding, where the laws of physics as we know them did not apply. Others propose the concept of a cyclical universe, where time and space undergo endless cycles of birth, death, and rebirth. What will happen to time when our universe eventually reaches its end? Will it collapse into a singularity, or will it expand forever, growing colder and darker until all stars burn out? The fate of time is intrinsically linked to the fate of the universe itself. Some scientists predict a big freeze, where the universe continues to expand until it becomes a cold, dark, and lifeless void. Others speculate about a big crunch, where gravitational forces pull everything back into a dense state, potentially leading to another Big Bang. These are questions that continue to baffle scientists and philosophers alike. The quest to understand time's beginning and end is not just a scientific endeavor, but a philosophical one as well. It challenges our perception of existence, reality, and the very nature of the cosmos. Theories abound, but definitive answers remain elusive. Some theories suggest that time might be infinite, stretching endlessly in both directions. This idea posits that time has no true beginning or end, but is an eternal continuum. In this view, the Big Bang is just one event in an infinite series of cosmic occurrences, each with its own timeline and history. Others propose that our universe might be just one in a vast multiverse, each with its own unique timeline. In this scenario, time in our universe is just a small part of a much larger, more complex structure. Each universe within the multiverse could have its own beginning and end, governed by different physical laws and constants. The true nature of time's beginning and end remains one of the greatest mysteries of the cosmos. As we continue to explore the universe and push the boundaries of our knowledge, we may one day uncover the secrets of time itself. Until then, the mysteries of time's beginning and end will continue to inspire wonder, curiosity, and a relentless pursuit of understanding. Section 8. Time in our universe, time in others. We experience time as a linear progression, but could there be other universes where time flows differently? Could there be universes where time moves backward, or where it branches off into infinite possibilities? These questions push the boundaries of our current understanding, leading us to realms of speculation and imagination. The possibility of other universes with their own unique properties, including the nature of time itself, is a mind-boggling concept to grasp. Yet it highlights the vastness of the unknown and the potential for endless discovery beyond the confines of our own universe. Section 9. Time. The ultimate mystery. Time is a fundamental aspect of our reality, yet it remains one of the most profound and perplexing mysteries we face. From the moment we are born, time becomes an integral part of our existence. We measure our lives in seconds, minutes, hours, days, and years, constantly aware of its passage. But what is time really? Is it a linear progression from past to future? Or is it something more complex, intertwined with the very fabric of the universe? It governs our lives, shapes our understanding of the universe, and yet its true nature eludes our grasp. Philosophers and scientists alike have pondered the nature of time for centuries. Ancient civilizations built monuments to track its passage, while modern physicists develop theories that challenge our conventional understanding. Time is not just a measure of change, it is a dimension, much like space, that we move through. Einstein's theory of relativity revolutionized our perception of time, showing that it is relative and can be affected by speed and gravity. As we continue to explore the cosmos and delve deeper into the fabric of reality, unraveling the secrets of time may hold the key to unlocking some of the universe's most profound secrets. The study of black holes, wormholes, and the Big Bang all hinge on our understanding of time. Could time travel be possible? Could we one day manipulate time to our advantage? These questions drive scientists to push the boundaries of what we know, using advanced technology and innovative experiments to probe the depths of time itself. Until then, time will continue to be the ultimate enigma, a constant reminder of the vastness of the unknown and the boundless wonders that await our discovery. Every tick of the clock, every passing moment is a step into the unknown. As we stand on the precipice of new discoveries, we are reminded that time is both a friend and a foe, a guide and a mystery. It is the thread that weaves the tapestry of our existence, connecting us to the past, grounding us in the present and propelling us into the future, the ultimate mystery indeed.